Hi guys, welcome back. Today we are going to learn about a subtype of random private address, and it's called unresolvable private address or a non-resolvable address. Let's see what a non-resolvable address is. A non-resolvable address is a randomly generated address which keeps on changing over the device power cycle. So basically it will change after a specific time period. It is really difficult to track this address because it keeps on changing. It's highly secure, but it does not have so many practical applications, as most of the BLE devices are just normally used to send some data which does not need security unless we have some special circumstances. So non-resolvable address must meet the requirements as per the BLE specifications. So the specification says that the most significant bit should be 0. So two most significant bits should be 0, and here the next requirement is the remaining all bits cannot be either 1 0 1 0 1 0 in this sequence. Other than that, they cannot all be ones, or they cannot all be zeros only. So other than these requirements, you can implement any other address. So basically this address is a random value which is generated by the soft device, so you don't need to worry about it, and it's going to automatically set these values according to the standard. So normally the most significant bit will be 0 0, and then we will have the remaining 46 bits to be of any random value, maybe any random value like this, and so on and so on. So in this way we set our random private address. So how to set the non-resolvable address? The first step is to define a private address structure. So this structure is basically the BLE gap privacy parameters T. We need to create a variable of this type of structure, and we will see this structure in the next slide. We will see what are the contents of this structure and how we assign them the values. So the next thing is we need to assign it the device address mode. The mode will be the privacy mode, the address type which is the non-resolvable, and also we need to set the time period. For example, we can set it to 10 seconds, or maybe we can set it to 15 or 20 or whatever value we like to set. We can set as many seconds as we want, and then after this timeout, the address will be changed automatically by the soft device. The next step is to call the soft device API function, which is SDBLE gap privacy set. And here in this function we are basically going to set the settings for the non-resolvable private address. So guys, now let's see what's inside the structure. So the structure has 4 variables. The first one is the privacy mode. The second one is the address type. The third one is the address cycle. Basically it's the time period after this timeout, and the address will be changed. And the last one is the pointer to the IRK, which is the identity resolving key. So basically for non-resolvable we will not use this parameter, so we will set it to as null, and we will discuss this for resolvable private address. So we need this IRK as well, so we will discuss it in the future tutorials. So for now, the first one is to set the privacy mode. So we have to set the privacy mode. The second one is to set the address type, so it's going to be non-resolvable in our case, or unresolvable, and sets the time in seconds. So basically this is the time in seconds. So we can set it to 10 seconds or 20 or 30, and whatever time is suitable for our application, we will set it according to that. And the last one, as I have already mentioned, the IRK, identity resolving key, will not be set in this case because we are using non-resolvable private address. Now guys, these are the basics of non-resolvable private address, and now we are going to see how we can program this. So let's jump into the programming, and let's create a new project for that. Okay guys, now we are going to start the programming. So first of all, open this PC, go into C directory. Here we have NRF SDK 17. Go into the examples and go into my projects. So previously we have seen that we did the random static address programming. This time we are going to do the non-resolvable address programming. So for that, first copy this BLE base project, because we are going to use the base project code, and let's name it as open this folder. And since we are using nRF5 2840, so I will be using PCA 10056. If you are using nRF 52832, you should have to use PCA 10040, where you will be using S132 as your soft device. So I will be using nRF 52840, so I will open this PCA 10056, and I will open S140. I will go into the SES, and here we have the EM project file. So let's open it. We have all the basic code here. So if you haven't seen my previous tutorial, just watch it and see how we make the basic application code. So just watch that tutorial and then come back to this programming. So make sure you learn about the advertising basis as well. Now let's write down the code. So first of all, I will go near the main function, and here I will add the code. So if you have seen the previous tutorial, there I added the random static address. So here in this case it will be non-resolvable private address. So in order to set the non-resolvable private address, I will use a setting function. So let's create the setting function. First of all, I will create a variable to hold the error value. Now we are going to create a gap privacy params type of variable, and then we will assign it the values. So for that, make sure it's static type. Let's name the variable as device address. Now we are going to assign it the values, as I previously mentioned in the presentation slides. So now we are going to do the settings here. So the first thing is privacy mode, and we will set it to BLE gap privacy mode, device privacy. The second thing we need to set here is the address type. So here the address type is random private non-resolvable. So for that we have this constant. The next thing we need to do is we have to set the cycle, the address change cycle. So for that, and let's set it to 15 seconds. So I'm just directly giving it a value. If you are using some professional code, you make sure you just define this value as a constant and then put it here. And the last thing is the IRK. So for this we will just set it to null, because we are not going to use this, so we will set it to null. We have done all the settings. Now we need to call the function. So let's call it. Here we will pass the address of the structure variable, so that will be. Now we are going to check if the setting was done successfully or not. So for that, now let's display a message. If the settings failed, then it would display us an error message. Now we have finished the settings. The one extra thing that I want to see is that if the address of the device is changing or not. In the previous tutorial we saw that the static random static address, we read it using a get function, but we didn't saw how to get it from PDU, that is the protocol data unit. So this time we are going to receive the address. We will see the address of our device through the PDU, because the address is changed. The change is reflected in the PDU. So we will read the PDU to see if our address is changed or not. For that I will create a timer. If you don't know about the timers, please watch my tutorial on application timers. I have already done a tutorial on this, so I will not explain too much details. I will just go through it so that you know how we can set a timer for a specific time, and then we can read the values of address from PDU. So for that, let's go above, and here is the timer initialization. So first of all, we need to define a timer. So we will go on the top, and here make sure you have included the application timer, otherwise this will not work. So first we need to define a timer. So here we are going to define the timer. Let's give a timer ID name. So for that, basically it's a timer to check the address. After a timeout, it is going to check the value in the PDU of the address. Once this is done, let's go down, and here we can see that we have the application timers here. Just here we will put our initialization code. So in order to create a timer, we need to use this function. So this is our timer ID, and the next thing we need to pass it is the timer mode. So it's going to be repeated, and it's not going to be a single shot. Now we need to define a timeout handler. For that, let's create a timeout handler here first. You can give it any name. I'm just giving it this name. And now we are going to pass this handler name. I'm just going to copy this and paste it here. Now we have passed everything. Now let's use the function. Okay, a timer is created. We will just need to start it in the main function. But first, let's write down the code for checking out the address in the PDU. So for that, first create a variable, which is the error code variable. Next thing we need to do is we need a gap address type structure, and we are going to create a variable for that. So make sure it's static. If you don't know about it, just watch my previous tutorial. This is the structure that holds the addresses. And let's say my device address. So this is going to be the variable, and now we are going to read the address using this function. The first thing we need to pass it is the advertisement handle. So make sure you pass it this handle, and this handle is defined here. If we go up, here is this ID. So we have to pass it. So this is going to be m advertising dot, and now we are going to check its advertisement handle, and here is the handle. Now we have it, and the next thing is we need to pass the structure variable's address, or the pointer to that. So and my address, and this is going to read the address and save it into this structure variable, and then if the reading is successful, then we can print this address. So here I'm just gonna print the address. So guys, that's how we are going to print the message. Now let's go into the main function, and there we will start the timer, and we will get the address. First we will set the address to non-resolvable private address, and then we will read it and print it out. So in the main function, before advertising, let's call the function, and now we will start the advertising. And after the advertisement is started, let's start the application timer. Let's pass the ID, which is the second one is time interval, and for this let's define a time interval. So if we go up here, let's define the time interval for this. So using this function, I have set it to 9 seconds, which is 9000 milliseconds. And so for this, we need to use this function to convert the milliseconds into the timer ticks. So this will do it automatically from inside, and it's going to do the calculation. If you want to know more about this application timer tutorial, first let's copy this, and then oops, I made a mistake here. Don't do this. Now we will go into the main function. Here let's pass the timeout. Let's pass it null, and now we are going to use app error check. Let's save it, and let's build the code. Okay, it's finished. First let's connect to the device, and then erase the device, and now let's download our application code along with the soft device. So now let's minimize it, and let's see where the serial port is connected. So for that, go into this PC, right click here, properties, minimize this, device manager, and here in the ports I will check my port, which is COM12. So I will open the PuTTY terminal, click on the serial, write down here 115200, which is the baud rate, and the COM port 12 was there. So let's open this, and here you can see it's printing that my device address is this, and the address type is 3, and 3 is basically non-resolvable private address 0x03. So here you can see after 9 seconds it's sending this. So the time period for the update cycle is 15 seconds that we set. So after 15 seconds the address is actually changing. So if you try to get the address directly, you will not see the update in the address, but if you check the address from PDU like we did in our code, then we can see that the address is changing after every 15 seconds. Now if we go to the Wireshark, if you don't know about this, just watch my previous tutorial on this. I have already covered this part, how to install the Wireshark and everything, so make sure it's there. Now we need to connect our dongle, so I will connect my USB dongle. Here you can see this is the USB dongle that I'm using. If you don't have this, you can use the PCA 10040 or PCA 10056, and this dongle has the model as PCA 10059. So you can use them, and there you can use any of them. How to program them, I have already covered this, you can see in the Wireshark tutorial. And now let's connect it. And once I connect the dongle, I will turn it off and turn on the Wireshark again, because it has to load all the plugins. So now it's going to load the Bluetooth LE plugin, and now here the NRF sniffer plugin is loaded. Now let's go double click on this, and it's going to open this. So here we can see there are so many devices which are advertising right now. So in order to filter out our device, first let's see where is our device. So let's go here and let's reset it, reset the terminal, and let it print the new address. It's 50 IE, and let's copy it. And now I'm going to minimize, and now I will place a filter here. So for that 6B, and this is our device address. So here we have caught 3A6B packets here, 3A6B79025C11. So if we double click on this, we can see its content, and the address header is this 0x8E, so it means it's the advertisement, and the packet has the address. Here is the address in the packet, and what it's advertising. The flags are these, the name is here, and the CRC is this. So basically we have this advertising address, and it's changing, it keeps on changing, and it's really difficult to track this address. That's it for the non-resolvable private address. I hope so you have learned something new today. If you are new to my channel, please be sure to subscribe to my channel, and please do support me, and your support matters a lot. And if you have any questions, you can ask me in the comments below. If you are new to my channel, please subscribe to my channel now, and hit the bell icon to get the notifications on time. Thank you very much for watching. See you in the next video.